Okay, today's topic in Unit 5 is slope. We're going to talk about what slope is and how to find it. Alright, the basic thing you need to know about slope is it talks and it tells you about the steepness or the slantiness of a line. That's kind of a slang way to say it. I'll give you the official definition of slope in a minute. But different lines have different steepnesses, or they're slanted in different directions. So slope gives us a number value for that kind of steepness or crookedness. Alright, so there's 4 lines here on the screen, and they each have kind of a different slant to them. This first one is going uphill. That is going to have a positive slope. It might be positive 1 or positive 2 or positive 3, but it's definitely going to be a positive number. This one, if you go from left to right, just like reading a book, goes downhill. That's going to have a negative slope, and again, that might be negative 1, negative 1.5, negative 2.3, but it's definitely going to be a negative slope. And notice that we're always going from left to right. On this line, however, it didn't go uphill or downhill. It's just a flat horizontal line. There's no slope to that line. So the slope of that is going to be 0. It has no slope. Our last line is vertical. And if Hello Kitty went on that line, look out Hello Kitty, you're about to crash. We don't say it has a positive slope or a negative slope. We don't even say it has a 0 slope. We say that that slope has an undefined slope because how steep is it? Well, it goes up and down, straight up and down. So we call that not 0, but we call that undefined. Okay, now match the words to the graphs. I'll give you just a second to try it. You might want to hit pause. Okay, hopefully you got that. And if not, you could rewind to this previous slide about positive, negative, 0 slope, and undefined slope. I think the one that you probably should be able to see is that choice C has positive slope because it goes uphill from left to right, just like reading a sentence. When you start from the left and go to the right, Hello Kitty's little car would be going uphill if she drove it on that line. But how do you find the actual value of the slope? Like, what's the number value of the slope of that line? Is this particular line going to have a slope of 1, or positive 2, or positive 3, or positive 2.7, or 1 1/3, or 8/9? How do you find the actual number? Well, you use the actual definition of what the word slope means. And slope is a ratio. Okay, we got to remember slope is a ratio. A ratio is comparing two numbers. In this case, the two numbers that you're going to compare are the vertical change on that line compared to the horizontal change on that line. In other words, how much it goes up and down versus how much it goes left and right. So it's a ratio of those two numbers. And if you look at that line, and if you kind of pick a couple spots on that line, you could actually put numbers to those up-down vertical numbers and the left-right horizontal numbers. So if you look carefully at that line right where it crosses the origin, the vertical change is it goes up 2 and then over 1, right? It goes up 2 and then to the right 1. So the slope of this line would be 2 because 2 over 1 is 2. Okay, if that didn't quite make sense, let's try another example. Okay, remember, slope is a ratio, and it's going to compare vertical change to horizontal change. So what if I connected 0, 1 with 1, 2? Notice my vertical change as I go up 1, and my horizontal change as I go forward 1. Okay, so my up-down change over my left-right change is positive 1 because I go up 1, and positive 1 because I go left. Nope, that should say right 1. Okay, going right once is like going forward once, so that's a positive 1. So what's my slope going to come out to? Well, what's positive 1 divided by positive 1? 1, right? That's as easy as it gets for slope. Let's try one more example. But first, let me give you a little slang term for this. Sometimes vertical and horizontal are too big of words, so sometimes people remember slope as the two R's, rise over run. In other words, how much it rises, how much it goes up and down, versus run, how much it goes left and right. If that helps, you can remember that. All right, what if you have a line like this? We can see that it's going downhill, so it should have a negative slope. If we take the vertical change over the horizontal change and look at that, we're going to get our rise and our run. Okay, I'm just going to start at this one point, and it goes down 1, 2, 3, right? That's negative 3. And from that point, if I go right 3, that would, oh, no, it went right 2, didn't it? So it went forward 2, okay? And so my slope is going to be a ratio of those two numbers, negative 3 over positive 2. And so I would say that the slope comes out to negative 3 over 2. And you can just leave it as a fraction because slope is supposed to be a ratio. We like it to be a ratio. If it simplifies to a single whole number, that's great, but a ratio is just fine. So negative 3/2 is our slope. All right, so here's your next practice problem. Try to find the slope of this line. Count the vertical change, count the horizontal change, and then put it in a ratio. All right, there's another way to find slope besides looking at the graph and counting the up-down number and the left-right number. Remember, slope is a ratio comparing vertical change to horizontal change, and here's the other way to find that ratio. That's kind of a weird looking little formula there. And what in the world is going on with the y2 and y1, and why is there an m there? Well, first let me just tell you that the letter that we use to abbreviate slope is m, which makes perfect sense because the word slope starts with an no, it doesn't start with an m. I have no idea why we use the letter m to stand for slope, and I'm not even going to try to make up a story about how the word slope is abbreviated m. You just kind of have to remember that m in math stands for slope. All right, the y2 stands for the second y, the y1 stands for the first y, the x2 stands for the second x, and the x1 stands for the first x. So what this formula is really trying to tell you is take the second y minus the first y and the second x minus the first x. But what the heck am I talking about with second y's and first x's? Here's what I'm talking about. If you have two sets of coordinates, two ordered pairs, you don't even need a picture of what the line looks like. You can just take the first y and the second y and subtract on the top, and the first x and the second x and subtract on the bottom. And notice on the top I have negative 1 minus negative 2. That's the second y minus the first y. You can pause this for a second and check the pattern just to make sure. And then on the bottom I have 2 minus 5. That's the second x minus the first x. Now I just have to finish the problem. Negative 1 minus negative 2 is positive 1, and 2 minus 5 is negative 3. So what's the slope between those 2 points? Negative 1/3, because a positive divided by negative is negative. And we're just going to leave it as negative 1/3 because slope is supposed to be a ratio. So the other way to find slope is using this formula, second y minus first y over second x minus first x. And if you do it that way, you don't even need the picture, you don't even need the graph. You can just plug the numbers from the coordinates in to find the slope. One more example. Let's say you have 0, 1 and 4, 2, and we connect the dots, and we're going to try to find the slope using this crazy formula. In this case, the second y is 2, and the first y is 1, so we're going to do 2 minus 1 on top. The second x is 4, and the first x is 0, so we're going to do 4 minus 0 on the bottom. 2 minus 1 is 1, 4 minus 0 is 4, So the slope of this line is 1/4. It goes up 1 over 4. And if we counted it out as vertical change over horizontal change, notice it goes up 1 over 4, and that comes out to 1/4 as well. So you can use either method to get your slope, and it should come out the same. By the way, does it make sense that this came out to a positive value for slope? Yeah, because it goes uphill. All right, here's your third and final practice problem. What's the slope of the line that goes through these 2 points? If you want, you can make a graph and count out the slope on the graph, or you can just use the formula, second y minus first y over second x minus first x. So here's a review. Slope is a ratio. You can find the slope using the vertical change over horizontal change, rise over run, or you can find slope using the formula method. Write down any questions you have. Feel free to rewind this and watch it as many times as you need to. And I will see you tomorrow.